In this section, you're going to learn how to manage traffic in your Istio service mesh. And the most powerful part of it is that you'll do it without changing your application code. First, we will talk about the core components such as gateways, virtual services, and destination rules. Then we'll jump into the traffic management concepts like subsets, timeouts, retries, circuit breaking, fault injection, request routing, and A/B testing. Let's have a look at gateways in Istio. Now that we have deployed the application and set up a service mesh, how can we make these services accessible to external users? In our case, the page that users need to view is the product page. How can we make the product page accessible to external users? Our requirement is that if someone goes to the URL http://bookinfo.app, they should view the product page with the details about all products. How can we achieve this? When we learned Kubernetes, we learned about ingress. Ingress controls traffic coming into the Kubernetes cluster. We learned that it is implemented by deploying an ingress controller such as an Nginx controller, and by defining a set of routing rules that route the traffic to the appropriate service. With ingress, we could configure rules to say any traffic to the Kubernetes cluster with the hostname set to the bookinfo.app should be directed to the product service. So here's a sample ingress object that we could create to drive traffic coming into the cluster at hostname bookinfo.app, so they are routed to the product page service. Now, this is Kubernetes ingress. While Istio supports Kubernetes ingress, there is also another approach that Istio offers and recommends that supports more Istio features such as advanced monitoring and routing rules. And that is called the Istio gateway. Gateways are load balancers that sit at the edge of the mesh. They are the main configurations that manage the inbound and the outbound traffic to service mesh. This is the recommended approach, such as compared to just using Kubernetes ingress. If you remember, we discussed earlier that when we deploy Istio on our cluster, it deploys two additional components known as the Istio Ingress Gateway and Istio Egress Gateway. These are Istio Gateway controllers, just like the ingress controller that we talked about earlier. The Ingress Gateway manages all inbound traffic to the services, and the Egress Gateway manages all outbound traffic from these services. We discussed that ingress is deployed in Kubernetes using controllers like Nginx. Istio, on the other hand, deploys ingress gateways using Envoy proxies. We have learned that all services have an Envoy proxy deployed as a sidecar container. However, the ingress and egress gateways are just standalone Envoy proxies, sitting at the edge of the service mesh. They do not work as a sidecar. These are the default gateway controllers that were deployed when Istio was deployed on the cluster. However, we can have our own set of customer gateway controllers as well. So our goal here is to catch all traffic coming through this Istio Ingress Gateway controller and route all traffic at hostname bookinfo.app to our product page. For this, we first create a gateway object. So here, we create a gateway object named bookinfo_gateway. It serves all HTTP traffic at port 80 coming to the cluster through the Istio Ingress Gateway controller with the hostname bookinfo.app. But which Istio Ingress controller? Here we have three controllers. The two custom ones we created, For this, add a selector and specify the label of the desired controller. In our case, we want to use the default Istio Ingress Gateway controller, so we set the selector Ingress Gateway. And we ignore the two custom ones we created. We then create the Bookinfo gateway by applying this configuration. To list the created gateways, run the kubectl get gateway command. And to view details about a particular gateway, run the kubectl describe gateway command. So, we now have a Bookinfo gateway object created to capture traffic coming through the default Istio Ingress Gateway controller through the URL bookinfo.app. But how and where is that traffic routed to? We will discuss that next when we talk about virtual services. Let us now learn about virtual services in Istio. So, we now have the bookinfo.app gateway. And users who are coming to http bookinfo.app will hit the gateway. But where to go from there? How do we route traffic through this gateway to our services? There are many different services. How can we specify that all traffic to the URL bookinfo.app/product page should go to the product page service? The product page service also serves static HTML/CSS and JavaScript contents at the path/static. There is also a login, logout, and API path. All of this should route to the product page. All routing rules are configured through virtual services. Virtual services define a set of routing rules for traffic coming from Ingress Gateway into the service mesh. Virtual services are flexible and powerful, with rich traffic routing options. You can specify traffic behavior for one or more hostname, manage traffic within different versions of a service. Standard and regex paths are supported. When a virtual service is created, Istio control plane applies the new configuration to all the Envoy sidecar proxies. So let's create a virtual service to route these URLs to the product page service. We create an object with the API version set to the networking.istio.io/v1alpha3 as of this recording. Note that this may change in later versions, so always refer to the Istio documentation while creating virtual services to get the latest supported API version. Kind is set to virtual service. Metadata has name, set to bookinfo, and we have a spec section. First, we want to say that only traffic to the host bookinfo.app hits this virtual service, so we added a host section. There may be multiple gateways configured. How do we associate this virtual service to the gateway we created for our app? For that, we add a gateway section and specify the name of the gateway we created. That is bookinfo-gateway. And finally, we have the HTTP section where we add our routing rules. The match section specifies URIs that should be matched. These are the URIs that we just discussed. Exact means the URI is matched as is, and prefix are the URIs that start with the specified URI, such as /static/something or /API/v1/product/something. All of the traffic matching these URI patterns are then routed to the destination specified in the route section. So, We now have a virtual service for product page. All traffic coming in through the Bookinfo gateway with the hostname bookinfo.app now hits this virtual service. Next, the product page needs to talk to the review service. At first, it only talks to the version 1. And later, we bring in versions 2 and 3. How do we gradually introduce the other versions and only drive a small percentage of traffic to it and test them before driving all to it? Let's first look at how this works without Istio or virtual services on a plain Kubernetes cluster. So, in the beginning, we have the product page service talking to the reviews v1 service. We then came up with 2 new versions of the review service, version 2 and version 3. Version 2 has the black stars and version 3 has the red stars. We want to test these services by driving a small percentage of traffic to it until we are sure they work as expected and that our users like the new star feature. In the plain Kubernetes world, without Istio or a service mesh, we would deploy the reviews microservice as a deployment. Let's say it has 3 replicas, for example. This microservice is exposed within the cluster using a service type of cluster IP. The label's app is set to the value of reviews, and that helps the service identify the pods as part of the reviews deployment. The service directs traffic to all the 3 pods. The product page can now refer to the review service to get reviews of a book. As of now, 100% of traffic goes to the reviews version 1. When we deploy a new version of the review service, say version 2, we create it as a new deployment. But to begin with, we only deploy 1 pod, because we don't want all users to go to that service. We use the same label though, a label called app with its value set to reviews. And as such, the same service picks up the new pod, part of the new deployment. Now, the service has 4 endpoints. As such, 75% of traffic now goes to version 1 and 25% goes to v2. Now with the 3rd version of reviews, we deploy a new reviews application. This too has a single replica and the same labels. So the service now has the new pod added as an endpoint. And now with the new pod, 60% of traffic is routed to version 1, 20% to version 2, and 20% to version 3. So, let's say for instance, we have identified version 3, the one with the colored star, to be the winner as users like that the most. So, we decide to route all traffic to that version. For this, we first scale up the replicas of version 3 to 3. So now we have an equal amount of traffic going to version 1 and version 3. We then scale down the replicas on version 1 and 2, and now we have 100% of traffic to version 3. We now have successfully run an A/B test to route traffic to the new versions, tested and identified the correct version to use, and then migrated to the new version of review service, all live and without any downtime or disruption to service. This whole process is the native Kubernetes way of performing canary tests and controlling traffic between different versions of services. However, this has several challenges. Earlier, we had 100% of traffic going to version 1. And then version 2 was deployed. We had 75% going to version 1 and 25% going to version 2. What if we need more granularity in distributing traffic between versions? For example, What if we wanted to send just 1% of traffic to version 2? So that the distribution is 99% to version 1 and just 1% to version 2. Since there are only 4 pods, and since the Kubernetes service distributes traffic across all of them equally, the distribution can only be 75 and 25%, not anything else. The only way to change the distribution percentage is to play around with the number of pods available in different services. So that's a limitation. With Istio and virtual services, we can now create a virtual service instead of a service, and we will call it reviews. We then define 2 destination routes for traffic distribution, subset V1 and V2. And we set a weight for each. 99% for one and 1% for the other. Now, we can route 99% of traffic to one service and 1% to the other. Even if the reviews V2 service had 3 or more pods, the traffic distribution would still be 99% to V1 and 1% to V2. The number of instances now has nothing to do with the traffic distribution, and we can easily control that through the virtual service configuration. Now, you must be wondering what a subset is and how it is configured. Well, hold on to that thought. For now, just think of it as a way of grouping multiple objects together using a label, like how a regular Kubernetes service is. But not exactly. We will get to that in the upcoming sections. Let us now have a look at destination rules. Destination rule applies routing policies after the traffic is routed to a specific service. Let's see what this actually means. Earlier, we talked about virtual services and how the review service can be configured with a virtual service to distribute a percentage of traffic to different versions. We know that 99% of traffic is sent to the subset V1 and 1% is sent to subset V2. So, where and how are these subsets defined? Subsets are defined in destination rules. So, we create a destination rule with the kind set to destination rule, name set to reviews-destination, and host set to reviews. We then define 2 subsets, version 1 and version 2, and provide labels under it. We set the version to version 1 and version 2 respectively. These are the labels set on the pods for the respective version of reviews deployment. This is how we define separate subset of services so that we can control the amount of traffic going to each subset. By default, Envoy load balances traffic in a round-robin fashion. This can be customized through the destination rule by specifying a traffic policy of load balancer. Set the traffic policy to a simple pass-through policy. This will route traffic to the host that has fewer active requests. There are other simple algorithms such as round-robin, random, and pass-through. What if we want to override a different load balancer policy for specific subsets? For example, for subset V2, we would like to have a random load balancer policy. For this, we can specify a traffic policy at the subset level like this and configure a different policy. This way, we can configure one load balancing policy for all subsets and a separate one for selected subsets as required. There are many more configurations supported by destination rules. For example, to configure a client to use TLS, specify simple TLS. Or to configure mutual TLS, set the mode to mutual and provide the path to the certificate files. One important thing to note is the host field here. It is currently set to reviews, which is the name of the service. It is the short name of the service. When using short names instead of fully qualified domain names, Istio will interpret the short name based on the rule's namespace and not the service's actual namespace. This might lead to misconfigurations if your service is another namespace. To avoid this, using fully qualified names over short names is recommended. Well, that's all for now. Next, we will see these in action in the demo videos that follow. So, let's try gateways in a demo. We already have a gateway configured. Let's check that one first. From the samples folder, we applied this gateway and it worked. As you can see, there's a wildcard in the host section. But how do we configure a gateway with a proper host name? Before doing that, let's get the product page deployment created again from the bookinfo.yaml to make sure we have all our apps running. And here is our gateway. And I'm going to delete this one. Now, let us create a gateway with a specific hostname. Here is the YAML we can use for that. As you can see, it is using Istio Ingress Gateway and allowing traffic from port 80 on HTTP protocol, and it will allow in only the traffic coming to the bookinfo.app host. For this gateway to take effect, we need to create a virtual service to handle incoming traffic. And we'll have virtual services demo later on, but it is important to note that hosts need to match with the one in the gateway and the virtual service. So, this virtual service is bound to the Bookinfo gateway we just created. In the virtual service configuration, there are some match rules and a route rule which we'll cover soon. For this gateway to allow traffic, we need to use bookinfo.app as our host in our request. In curl, we can add the -h flag to set HTTP header to bookinfo.app. Yay! It works! Now, our Bookinfo application is open to outside traffic using our Bookinfo gateway. Let's check it on Kiali's Istio config section. Here is the gateway, and you can also change some configuration from Kiali. And here's the virtual service we just configured. Let's go to our browser and try this hostname now. And in order to do so, we can add the IP and hostname to our host file with this command. Now let's try it. Here, in my browser, I'll type http bookinfo.app my port number / product page. And as you can see, we could go through the gateway we just configured using the bookinfo.app hostname. Now, I want to go back to the gateway and change the hostname back to wildcard. Because throughout this training, we might need to go back to default configuration using sample YAMLs to have a fresh start. And as you might remember, we had wildcard in the hostname. So we'll stick to that format through this training and use IPs instead of hostname, if there's no specific use for that. Now, we can also revert the hostname in the virtual service back to the wildcard as well. In this demo, we'll create some different subsets using destination rules and forward our traffic to those service endpoints grouped together. Before that, let's have a look at our existing destination rules for reviews. We have three different subsets, and they refer to the labels as version v1, version v2, and version v3. Here in the virtual service, we simply use these subsets to route our traffic. But what if one day we somehow needed to group different deployments together underneath the same service with a different rule or label, let's say? To do that, first we need to add a new label to our app. This new label will help us create some different destination rules. Here, I copied the reviews YAML from the samples directory. First, I'll add test beta label to review service. Then I'll skip my first deployment